everyone. I'm thrilled to be here at .NET Conf, and this session will be about the lessons we learned when we migrated from Newtonsoft.Json to System.Text.Json on a quite large project. The project is actually an open source framework for building web applications, so it's not a common web app that would just expose some APIs. We did quite advanced things with JSON, and the differences between these two libraries are quite significant. So in this session, I will go through quite interesting scenarios we run into. My name is Tomáš Herceg. I'm a Microsoft MVP from the Czech Republic. I'm running a small software company called Riganti, and I'm maintainer of DotVVM, the open source framework, a member of the .NET Foundation, and the framework I will be talking about in this session. The things I will be describing are relevant for you if you are trying to modernize some REST APIs. Typically, if you have a web application written in .NET Framework, which is using ASP.NET Web APIs, and you are trying to migrate it to the new ASP.NET Core, because then probably you will switch to the new library as well. Also, if you have been using ASP.NET Core since the first versions and for some reason you used Newtonsoft.Json and now you feel that it's the time to finally convert to System.Text.Json, or if you are like me and you maintain some library which usually wants to support both .NET Framework and the new .NET, but since System.Text.Json runs also on .NET Framework, then this migration can be interesting if you are if you are a library author. So before I start showing the use cases we have run into in .vvm, I would like to just shortly, briefly describe what .vvm is and what we actually do with JSON. So as I said, .vvm is an open source framework for web, and it's using MVVM, model view model approach to design your applications. Basically, you just write an HTML file with some data binding, and then you accompany it with a view model written in C#, so you don't need to write JavaScript. And basically, the framework will make sure that the view model is accessible in the browser, and the MVVM experience with the two-way data binding happens there. So in short, .vvm needs to create a C# view model and then render the HTML page and serialize this view model in JSON and send it to the browser as quickly as possible. And if the users do something with the page, for example, click a button, if they, for example, want to submit an order or save a customer or something like that, this requires some server-side action. So in that case, the view model is deserialized, and basically the changes are applied to the C# object. And because sending the entire view model from the server to the client and back could be use quite a lot of bandwidth. The view models can have hundreds of kilobytes. So in this case, we are doing JSON diffing. So we are just comparing two versions of JSON and sending only what changed. And also then we need to apply this diff to an existing view model or a JSON object. So we also do JSON patching. And because some parts of the view model might need to be protected, so nobody can even read it on the client, or if they can read it, they shouldn't be able to change it, we implemented our own encryption and digital signing mechanism that you can apply to some fields in the JSON or some sub-child objects, some subtrees. So part of the view model can be protected by a digital signature, so the user will not be able to tamper with that. Just to have a better idea how the syntax in .vvm looks like, so on the left side you can see the HTML with our custom components like a text box or a button and data binding syntax. This is somehow translated to JavaScript, so you don't need to write it, but that's handled by the framework. And on the server side, you declare a view model. So here we have a simple C# class with an integer property called number and a method which can increment this number. So whenever you do something on the client which requires server-side cooperation, you can do also local changes in the view model, but these are not that interesting from the perspective of this session. So once you invoke an action on the server, the view model has to be JSON serialized, sent to the server. On the server, we need to deserialize it, run this increment method, and then serialize the changes that were made to the view model and send them back to the client. So the page on the client side, it stays loaded all the time, and the view model lives sometimes in the C# version, sometimes it lives as a JavaScript object while the user is looking at the page, and these transitions are transparently handled by .vvm. As I said, we implemented a couple of advanced features. So for example, this first property says bind direction server to client, which means that this property is only sent when it's going from the server to the client. So it's part of serialization. But if the client would send it back, it would be just ignored. Yeah, so like we need to conditionally include some properties based on this attribute. Also, there are other things. Some properties are just sent to the browser, but they are never updated. The list of countries can stay there while the page is loaded, and it will never need to go back to the server and back from the server to the client. So this means the server to client first request. And as I mentioned, you can, for example, digitally sign some parts of the view model. So this needs to be readable because you need to display the total price in the browser. However, if the user would try to change this property and send this modified view model to the server, it will not be allowed because we also keep digital signature of the fields that we protected in this way. And this is a part of view model. There is some special property called encrypted fields, and that contains signatures for all the data in the view model that should be protected. So as when we were trying to change System.Text.Json as a new backend for the serialization and the view model in our .vvm repository, we kind of thought that it would be quite easy because there was just few places where we call JSON convert serialize or JSON convert deserialize. Then we found out that's not that simple because we didn't do only this. We were also building the J objects, which is basically a tree of objects in the view model. We were building it, we were reading it, we were comparing these trees because of the JSON diffing and patching. So what was initially thought to be quite simple was actually this big pull request with 252 changed files. And that's the reason why I'm speaking about that, because I think that this can be useful to see for other people who want to do a similar change. We, after this pull request, which was merged almost 1 year ago, we did a couple of smaller PRs with some bug fixes or some additional features. We found out that the old version with Newtonsoft.Json supported, and because System.Text.Json is a different implementation, they behaved in a different way or they were missing. So the first thing that you would probably expect is that the new implementation has a different API for defining your own custom JSON converters. So if you use Newtonsoft.Json and you have implemented your own JSON converter, you will need to rewrite it to System.Text.Json. They are not that different. There are different base classes, some namespaces, some enums were like changed, renamed, but overall it's a lot of trivial changes in the code. So basically you will change the base class, you will run the compilation, you will see the compile errors, and then you need to go one by one and fix these. Nice thing is that the System.Text.Json is using UTF-8 encoding. So if you want to, for example, compare the property names, you can use these new APIs that will allow you to compare this property name or value with UTF-8 literals, which basically this function accepts something like read-only memory of byte. So because one typical performance bottleneck in JSON serialization would be that you are creating a lot of strings. System.Text.Json doesn't do that, so this is more efficient than comparing with a string, which allocates twice as much memory. Yeah. So we had to rewrite all JSON converters, and we found out we have quite a lot of them because the framework needed to do various things by using the converters. We had some breaking changes in some objects, so we wrote JSON converters to produce the JSON in the same format without these breaking changes. We also, for one feature of .VVM, we changed the way how dictionaries are serialized to the client. We also want to provide the users client-side type annotations. So .VVM serializes some type metadata in the JSON object. I already mentioned the encryption and signing, which is also done by converters, and the serialization attributes that affect the way in which the value could be or could not be serialized. And we also implemented a custom handling for dates because in some cases it was behaving quite unpredictably with respect of whether the date time is local or UTC. So we built a custom converter that somehow fixes this behavior to be more intuitive for the users. Another feature of Newtonsoft.Json was that you could decorate entries in Enum with this Enum member attribute. It's part of system runtime serialization namespace, a built-in namespace in .NET, and you can provide custom strings for these values. So instead of if you use the JSON string converter, JSON string Enum converter, typically the result would be 0, the word 0 in the JSON. But if you want to change that, you could specify this enum member attribute, which was supported by Newtonsoft.Json. System.Text.Json has a similar attribute, but it's called JSON string enum member name. And because we are implementing a framework, then we want the people who already had enums with this attribute, we wanted to support that as well. So we had to implement our own enum converter, which would look at these attributes and these old attributes and implement other logic as well. For example, also there are some special cases when you serialize enum, which has flags, so there are the bitwise combinations of the options. So we also needed to tweak this a little bit. If you were using System.Text.Json 8, it didn't have this attribute. This appeared in the version 9. So we are glad that we can support it as well. Newtonsoft.Json had a little bit unknown feature called should serialize pattern. If you want to conditionally include some property in the JSON based on some other condition, then you could declare a method called should serialize and the name of the property. And this method could return a Boolean value saying if this property should be included or not. So in this example, for example, I have a customer who has some name and a flag if it's a company or a person. And if it's a company, I want to include also this company number property. So basically, this should serialize company number function is true only if the customer is a company. So if it's just a normal person, only the name and is company false, would be present in the JSON. However, if it's a company, there will also be this company number property. This is not supported in System.Text.Json yet, so we had to implement that. Again, we were not using that in the framework itself, but we weren't sure if some users might try to use that, so we implemented that as well in our converters. System.Text.Json handles inheritance in a different way than Newtonsoft.Json. So in Newtonsoft.Json, you had to turn on some type annotations, which would basically render a $type attribute to every object. However, because of some security reasons, this is not very much recommended approach, because anyone can send you any type, and some types, when you try to create them, they are not doing very nice things on your machine. So basically, this is discouraged in System.Text.Json. Instead, you need to, if you want to use derived classes, you need to explicitly allow them with this JSON derived type attribute. So we had to somehow detect that polymorphism was used in the view model, because we supported it in some scenarios with some restrictions. However, in System.Text.Json, it doesn't work. So we just had to detect the cases and throw exceptions. Otherwise, we would suffer breaking changes. And sometimes it could be just by mistake that somebody is using some refactoring tools and some property remains of type object. So there is polymorphism involved in that in every case. So we want it to be not to break too many people. Another issue is the naming policies and how are the casing of property names solved in each library. If you try to use these libraries in a standalone version, like call JSON convert or JSON serialize or .serialize, then the defaults are quite similar. So both are using Pascal case, and so the same name as the C# property would appear in the JSON. However, if you are using ASP.NET Core Web APIs and System.Text.Json, by default, it's configured there to be camel case. So if you are migrating some APIs from old .NET framework to the ASP.NET Core, just be careful that you configure the same casing. Otherwise, you will have a breaking change, and sometimes it's not very obvious to use. We had one scenario where we changed accidentally the casing in ASP.NET Core. So suddenly the API endpoints started to return different property names, which were different by the uppercase letter in the beginning. And because our client was written still in Newtonsoft.Json, we didn't notice that, because Newtonsoft.Json by default is case insensitive when reading the JSON. However, other clients who migrated to System.Text.Json earlier, they reported this breaking change to us. So it's a little bit tricky, because Newtonsoft.Json was less strict in general than System.Text.Json is. So when going from less strict environment to more strict environment, you will probably run into some tiny differences. Another thing that worked with Newtonsoft.Json, some people, they want their model objects to be a little bit safer, so they prefer using private setters. And to make it work, you need to explicitly specify JSON property in Newtonsoft.Json. So that was sufficient. So people used private setters and applied JSON property attribute on that. And it worked. So Newtonsoft.Json called the private setter while deserializing the object. However, in System.Text.Json, if you just fix the compile error that the JSON property attribute would be renamed to JSON property name, that's not enough. You have to add explicitly this JSON include parameter attribute. Without that, this property would not be deserialized because the setter is private. So the deserializer will just ignore it. It will say, no, I cannot set value in that. You have to explicitly include that. So be careful about this, because if you just fix the compile errors, change JSON property to JSON property name, that's not enough in this case. We had quite a lot of issues. Also, there was some code generation tools which generated objects like that, so we had to fix these tools to add this JSON include attribute as well. And that's just a bunch of the issues we run into. We found more differences. However, they were more caused not by the differences in the libraries. They were caused mostly by our customizations and our custom converters. So I'm not mentioning that. We did some benchmarks. Currently, we have a benchmark just one way of the data serialization. And the results of this change are quite nice, because we saved about like 60 to 70% of time while serializing the view model. However, to be fair, this difference is not entirely because of the differences between the library like Newtonsoft.Json versus System.Text.Json, but we were also doing some things that were not that much efficient with Newtonsoft.Json. On one place, we were building JObject, which is an object representation of the JSON tree, and then calling toString on it. However, the new implementation writes everything directly to UTF-8 JSON writer, which is, of course, a little bit faster. However, we can still go a little bit further, because on some places in the framework, we still use the serialized view model as a string. If we keep it as a UTF-8 byte array, we would save also some memory allocations, and it would be easier, because now we use UTF-8 JSON writer. We then convert it to string, and then converting it back to UTF-8 to send it over the wire, or have ASP.NET Core to do this for us. So like these are unnecessary conversions. Even with those, we are faster than we were, but we are also trying to get rid of this final piece. And we expect quite similar performance benefits on the reading side, on deserialization side of this, because System.Text.Json allocates much less memory. Basically, you just get the input, and then System.Text.Json is just looking at ranges of this one input. It's not creating bunch of strings for reading and accessing every property. So that can also help us to reduce memory allocations as well as increase the performance. So we are really thrilled about this change. If you are interested in more details, you can look in our pull request. However, be prepared that it's a lot of changed files, so it can be a little bit difficult to navigate through. So if you are just migrating an old application, you probably not run in all these changes, all these details I pointed out. Just in some cases, it can be a little bit tricky. For example, adding these JSON include attributes, which you will not get a compile error for. For most things, when you do migration, you will get compile errors. So it's quite easy to go through all of them, change namespaces, change the names to the new ones, because some things were renamed. However, if you fix all compile errors, you should be 95% or 98% ready. However, there can be some subtle scenarios where you need to add something or tweak something, and you will not get compile error for that. So be sure, for example, to generate OpenAPI definition and then compare it if it's exactly the same. If you are building a library, it's a little bit more complicated story, because you may still want to support .NET Framework. And the good news is that System.Text.Json runs also on .NET Framework, even though it's not that fast as on the new .NET. But typically when you are serializing something in a library, you have much wider area of features in this serialization that you expect your users are touching. So if you just serialize your own stuff, then you are quite aware of what features you use. However, if you let anyone serialize anything through your library, then you don't know what feature set your users are actually taking advantage of. So that's a little bit tricky. We had years ago, we did one mistake. We relied on global JSON serializer settings. Newtonsoft.Json had a static instance of the configuration anyone could change. So if people change it, they broke our framework. So then we had to create our own, but also that produced some breaking changes. So if you are making a library, make sure you don't rely on any global settings, because this serialization to JSON can be used by multiple libraries with different settings. So make sure you have your own settings. And the last note is that the converters are very powerful because they allowed us to do a lot of crazy things, extend the serialization with a lot of advanced features. Of course, these converters we wrote are not simple, but the nice thing is that the infrastructure in the parser actually makes this possible. So it's great that both libraries are very extensible. So that was just a short brief what we did in .vvm framework. If you didn't try .vvm and you want to see how to build web apps with just HTML and C# using model view model, which you may know from .NET MAUI or Xamarin or WPF, check out .vvm.com or check out our GitHub. Enjoy the rest of .NET Conf.